Testability is a key concept in professional software testing. We may be called upon to test things that are very complex and very difficult to get at. They may involve complex relationships between input and output. How do we test something like that? We're going to have to test something like that by asking for testability, for getting testability designed into the product. In the session that follows, Michael Bolton and I grapple with the testability of a particular JavaScript-based data visualization. I think you'll find it interesting.
Okay, what you see here is a hierarchical depiction of a set of files in a directory. The size of the
Sorry, shrink it down a little bit so I can see the whole circle. I can't see the whole circle in my screen. Oh, okay. So, all right, it's like that.
The
right.
size of each circle is proportional to its size on the size of the file or folder that it represents on the disk. So it's a nice little hierarchical depiction. But a question arises, is this an accurate depiction of that hierarchy? Is each circle the correct area?
Relative
if we want to test
the other
this,
circles, yeah.
then we have a bit of a challenge. So, what do you suggest, Michael?
Well, let's see. Each circle needs to be proportionate to each other circle within its own circle and on the screen overall. Right away,
I think the proportions have to be correct within each circle on the same on any given level.
Okay, because it occurs to me now that I look at it that, for example, that circle right there, there's a bunch of blue on the outside of what seems to be, I get, are those files in there? If this is a directory structure, are those the big circles files, or are they other directories?
The big circles are either directories or files. If there's something inside it, then it was a directory.
It's a different color. Okay. All right. So then it seems to me that we've got a basic issue, which is it can't be that the enclosing circle is correct with relation to the circles within it because there's all that empty blue space. But I guess we can look at each file in turn and see
each level in turn.
Right, each level in turn and see if the
each file on that level.
Yeah, okay, that makes sense.
Right.
So
we can here's just as an example.
Yeah.
Let's take an easy one. Let's go.
Whoa. Oh, there's a bunch of tiny files.
Right.
All right.
Let's take let's do this.
Okay.
I'm going to make this big, make it easy on myself.
Okay.
And I have two files here, jQuery min.js download, all viewer JS download, which is in this directory.
So that's down. So there's no subdirectories there.
Good. So let me find those files first, and I shall find them
on the file system
by going to the directory structure that this was created from.
Okay.
Which was in, oh, that's not it. Where are you? I'm looking for the directory I brought up. Oh, there it is, apps to test. I'm looking at the wrong screen. Right, this is the directory, it was file differ that had all this stuff in it. So if I search for the name of that file, which is
that folder you mean?
Well, I don't have the name of the folder.
Oh, that's it.
There's no name in the folder.
That's actually kind of a flaw there. I'd say that makes testability harder because we can't see it.
Yeah, it'd be nicer if we had the if we had that, definitely. Okay, so it looks like we've got one, although it occurs to me there might be more than one in this structure.
Yeah.
But we have one here, which is under, oh, we have got a zillion of them. Maybe it doesn't matter which one we look at, because they're wherever we find one, there's going to be an allviewer.js download right next to it.
Right.
We just need to find an example of that. So if I say open, I want to
Open
open
file location down below.
Yeah, where is open file location?
At the bottom.
There
you go.
I want to open file location. Okay. So I've got these two. Now I can say what their size is. They're 59K and 133K.
Okay.
Okay. Can you make a note of that? 59 and 133.
59 and 133.
Well, actually, we could
put that up to the side.
We could know in greater detail by CDing to that area.
That's true.
And being there, we can say dir, and we can find out exactly what it is. Okay, so we have. So what we have is 59395 for one, and then the other one is 135228.
Okay, so for the renderer, where did this data come from for the thing that's rendering the visual on the screen?
Okay, the data came from a program that I wrote, which walked through the command line tool that walked through the directory structure.
Okay, yeah.
And that program looks like this, and it recursively walks through and creates a JSON. The JSON is then stuck right into the HTML and JavaScript file that creates the visualization. So this is the JSON right here. You see it has all of the file sizes in it.
And
I'll bet you if we search this for,
there's one right in front of you.
Of one of those files?
It's right in front of, no, there's one right in front of your eyes right now. There they are. But we were looking for one of a particular size. Go back to the command line and we'll look for the one that's of exactly.
We want a particular one. This is one 135 139.
Right.
135 228. I remember that one.
Yeah, 59 and 133.
But there's another one that says download. That's the actual one we were looking at. Download.
Okay, download.
And if we search for that, oh, there it is. That's what it is. So we have 45950.
Yep.
And then we have
59 and 149. That's not the same one. Go to your command line again.
It's not the same one.
There's a bunch of different ones. Okay, so 135.228. Can we find? Just look for that string in Notepad++ there. 135.
Okay, so we look for 135.228.
228. Right. No commas. Control F.
Where? Why did it Control F? 135.228.
228. Yeah, find it. There it is.
There's
several
of them.
All right.
And so here's one that has the all viewer download in it 59395.
And let's go back to the other side and see. Yeah. Okay. So was it 59395 there? Yep, yeah, exactly. Okay. So cool.
So this at least shows a consistency between what DOS reports, what Windows reports, what the file system reports, which is pretty reliable.
That's fairly
what my tool came up with, which was a Perl tool. So Perl had to correctly come up with this. Now we could still question whether the tool has put all the files in the right places, and we can look into that. Absolutely, that's something worth testing. And we know that there could be bugs in that. But for the moment, we have a prima facie case that a sanity check that
it can work.
Yeah, it can work. It might be working.
All right, so that's good.
Some positive reason to believe that. So
Right.
now this is a JSON. The JSON is stuck inside this thing. So then the question is the actual visualization the correct visualization? So one way we can do this is I can load up my old friend PicPic, which is a portable tool that I will show you. Do you want to change? No. This is PicPic, which is I got from portableapps.com. And one of the things it has is a pixel ruler.
Okay.
Okay,
So
so I'm going to bring up my pixel ruler.
a little more refined than eyeballing it then.
A little more refined than eyeballing it. Yeah, yeah. So what we can do is set this thing out, and we can, and they're nice handily right next to each other.
Oh, that is convenient.
So I can try to say, what is the actual size of this? And it'll be pretty close. It looks like it's 400 pixels for the big one.
Yeah.
And then the other one, do a subtraction. It starts at 460.
460.
And it ends at 725.
725. So gee whiz, that's 45, 65, 265, I'd say.
Okay, so let's bring up the calculator. And oops, calculator.
Whoa! Hey, that didn't happen before.
What?
That's cool. Well, the file names are all there on all of them.
They're conditionally there depending on whether they fit. Okay, so we have two circles, right? So what was the first
I forget what the first one was.
diameter? You wrote it down, right?
No, I wrote down the second one. I wrote down the subtraction.
Okay, I thought you were helping me here. Okay, let's do this
Oh,
again.
but no, we've zoomed
this
it.
again.
We've changed the zoom level though. So
It's
there's 400.
it's a fixed 400. So the first one was 400, and the second one
was 265.
That sounds about right. Okay, it looks about right. Okay, 400 and 265. So we can just do
265 over 400.
200 squared. What? Yep, 200 squared.
Why 200 squared?
Because it's pi r squared is the calculation of
oh, right. Okay, right. The radius,
so,
right.
So r squared times pi 3.14159265355.
Now you're just showing off.
793. So here is the area of the first one. It's 125,664.
Hang on, let me write that down. Yeah. Sec.
Although
125.
I think it's going to be right here.
1,
so
2,
then the other one is you said 265. So let's just go
265 by half.
265 divided by 2
times pi.
And let's square that, and then let's multiply it times
That's true. We're
pi.
going to square it before we multiply it by pi. 8, 9. It should be 90 actually.
It gets end up to
55154.
All right.
Probably close enough.
So now let's see what the ratio is of one to the other. So if I go,
it already looks pretty close.
Does it actually let me click on this? Maybe I have to copy and paste.
Well, I've got the numbers. I can just read them off to you.
Always wonder if there's an easier way to do these things. Okay, divided by
55154.
And we get
2.278.
All right, so basically 2.3. Now, what is the
file sizes? Go back to your DOS window.
Now we need the file sizes.
Go back, so go back to your command line window. That's 59395.
Okay, let's do 5. Well, the bigger one first.
Okay, so just move your calculator window over a bit so we can see. There you go.
There we go. Okay.
So
So
the big one first, 135,228.
135,228 divided
Divided
by
by 59395.
59395 equals
227.
2.27.
Boy,
Quite close. Very, very close.
Yeah,
Very,
good.
very close. Let's say it's close enough for human eyeballs.
But that's just a spot
So
check.
this is a spot check. Yeah, now all we have to do is the same thing with every other circle.
It's literally a spot check.
Every other circle in every level, and we will know the truth.
What? But do we
And that's
need
how
to
to
do
do it.
that?
Well,
Do
I
we
sure
need to
don't
do that
want to
for
do it.
every circle?
I don't want to do it for every circle, but
So what's
maybe
the
there's a
risk?
better way.
What's the
Now,
risk?
there is a better way.
Yeah,
And a
we could
better
ask
way
for
is to
testability.
go and, yeah, we can ask for testability. Well, but we already have testability. Here's why we already have testability. Because if I view page source, or actually it's a better way to do it, which is I press F12,
Look at the DOM.
I can look at the actual DOM. This is what's created by D3. It creates the SVG. So I actually have all of the coordinates.
You don't, yeah, but there's something that there's no reference there to which file name it is.
That seems to be the problem.
So where's it generating? Where's it generating these nodes?
It generates them in the JavaScript up above. But let me just make sure I understand this. R92, I think this R means this is the radius.
Well, I'm seeing 2 points there. Translate.
This is probably the center, and this is the
Yeah,
radius, is what I'm
yeah,
guessing.
yeah,
So that means we can grab the radius. We have that right now, no
yeah.
problem.
Good.
We might even have be able to find, by searching. Well, the radius is approximately 400, but it's probably not going to be exactly 400. But we
Yeah.
do need to be able to discover the name of the file, and then we need to find out where it is in the hierarchy as well, but at least the name of the file.
That'd be a good start. Let's see the code. Let's see the code. So just to be clear, what we're seeing here is little nodes that are going to get displayed on the screen, but there's no IDs. There's nothing there to distinguish which one refers to which file. So we got to look at the JavaScript and see where that's being generated. Okay, so wait,
Well,
not too fast, not too
let me
fast.
bring up the JavaScript in the editor. That might be a little bit. So let's
walk through it.
How about
D3? That's what is that? Is that a drawing library?
Yeah, it's a JavaScript library that does vector graphics. They say data-driven vector graphics. So it creates SVG diagrams that you can interact with right in the browser, based on code that you write. So here's the code
for
that
circle.
I copied from the website where I learned this.
Okay, but right there I see something varicircle equals. So that's the code that draws the circle. Data, adder. Oh, look at that. Adder class and style fill. That looks like they're creating the line for the HTML.
Yeah.
Go back to the other side.
Other side of what?
Go back to the DOM that you were showing before. Just flip to that window. And we'll see if we get an instance of that.
Where?
No, down where it was drawing the circle. Drawing the circles. That list of circles that you had before? It's not in the script. It's in the SVG up there.
Oh,
right
that.
There. Yeah.
Right.
Okay, so circle
class equals node. Yeah, it's
and
all
style. So it's got that's where it's drawing the class and the style information in the code. Okay, that's cool.
Right, but we don't have the names of the
files. Right. Okay. So flip
So what
back
do
to your source
How do
code.
we get that?
Okay.
Okay, here's the source code.
Okay. So adder class, it looks like a straightforward thing where when it writes the attributes and it writes the styles there, dot adder dot class, I can infer from what I'm seeing that we could put another adder on there if we could find the name of the file that it was referring to and make that the ID, right?
Okay, so you want to add an ID.
Yeah, but what? Okay, well,
Well, we want to add an ID that's the file name.
okay, so let's start
Well,
with,
you know what? Let's start with that then. Let's just add the thing.
and see if it adds an
So
attribute full stop.
so we have a trinary here. It seems to be adding the word node. So I could just
Or
say,
node leaf or
you
node
know,
root.
data, and then I could say
ID,
ID here.
right? And get,
Um,
you
but
don't need anything after the other stuff, right?
we don't
You
need
just do it in every case.
So we don't need the trinary. The trinary here is selecting between leaf and root, and we don't need that. So
We just return data.
we just return data. Oh, yeah, that's right. Okay. So we just go data, and we just
Take out the
return
other
that.
stuff.
Okay. So that should just add the ID of data to everything, right? Let's see if it does that to
every line.
just check if that is the case. And we do that by refreshing this and then going back to this,
The DOM.
the DOM, and scrolling
Nodes.
down.
Woohoo!
ID data.
Yeah.
So now what we want to do is make instead of just saying data, actually get the real thing going. So
That's nice and super clean. That's good.
Let's come back to this. How do we get the name of the file though? Now that we know that there are labels in that document that show up when you zoom in. So there must be something down here that's saying what the labels are.
You mean
okay, that
the
says
file
label.
names that get displayed on the screen? Go back to the screen again.
I'm just searching for label. Let's see where label shows up.
The word, okay, Control F for label then.
So that's a CSS.
Right. So there's
It only
those
shows up in one place. It shows up right there.
So where's it getting it
So
from?
this must be where it assigns the label. Look for anything. I think this is it. D data name.
Oh, wait. Okay, slow down a little bit. Let's go to the, show me what you see on the screen. Go back to the circles.
Yeah.
Okay, so click on that and click again so I can see it a little bit, or zoom in or something. So it's a thing that's labeling the circle.
Yeah.
Is that what it's doing? And that is the file name of the file. Inspect. See, I don't see labels showing up there.
Yeah, but it must be there because it might be that I'm just not clicking on exactly the right place. You know, there is somewhere there I would be clicking on something that would see a label.
So zoom it up really big until we can see the label really closely, and run the
oh, okay, let's try.
the
Yeah,
little inspector.
We can just try the zoomer.
Yeah.
Just
zoom. Yep.
Just
okay.
use
that. Now bring up the inspector.
That.
Can you do that? F12.
Where you sit right on it like that?
I don't no inspect. Yes, I guess.
Yeah,
or
see, I don't know. I don't know if I'm actually on the label.
What about the little
when
arrow
I'm doing
thingy?
that?
The little arrow thingy up in the left corner, the upper left corner. Farther up, farther up, farther up. There, that. Select an element on the page to inspect it. Doesn't that highlight the thing that you're hovering over so you can see it? Right there.
Okay, let's see that. I'll highlight over some things. It just selects the entire circle.
But what about the words there? That's got to be somehow.
Can I search for that label in the
DOM?
Yeah, if I go.
Oh, look, there it is, right there. Text.label. Yeah.
Text label. Ah, I found it.
Text.label. Right.
Yeah. Here it is. Here it is.
Okay.
There it is.
There. Okay. Oh, look, there's the name.
Yeah.
But
So text class label transform. So it's saying where to put the thing.
where to put it? Okay.
So anyway, that's where the label is.
And that's what the label is too.
But how it is
Obtained.
actually set, we've
Right.
already established that. That's right
Oh,
here. This is the only place in
you're
the
right.
code where it says label. So it's getting
It's got to be
return
there.
data
Yeah.
name. So why don't we do this? Why don't we take that and
Control
go
C
up
it.
to where the ID was, and instead of return data, we
Data.
say return data name. And if that's
Right.
still in scope and all that, then which it should be.
Try it.
That so let me go back down to that's 100%. Let's redo this. And now when I say when we look at this,
Woohoo! Look at that. Did you see it? It went by really quick.
I
Expand it
was
again.
just trying to refresh it. Oh, ID, and now we have the names. Okay, so now we know that this radius is associated with this file, and we already know that what the files are in the hierarchy because we have the JSON that's above. So I believe now I have everything I need to write a program that reads this DOM. If I can save this DOM, can you actually save it? I actually don't know.
Break on.
Because oh, maybe I just say save. Can I just say save as, and will it save the?
It'll. I guess. Yeah. Right. Sure. It should. PackCircleDemo.htm and put something on it to so we don't get a collision later on, like PackCircleDemo test.htm or data or DOM. Put DOM on the end of that there.
And then now let's see if we can actually get it, which would be nice if that were the case. So I'll bring this up and open this, and let's hope that DOM stuff is there.
Look for
Sure is.
ID.
It is. It is. Look, that's it.
Okay, but can you look for? Oh yeah, there a class equals no leaf, but where's the ID on those circles?
Right there.
Fantastic. So, oh, but there's a catch.
What?
What if we have two files of the same name somewhere in the data?
Well, that's okay because we need to know what the hierarchy is.
Yeah.
So either I can analyze this to reconstruct the hierarchy, or we can assume that the hierarchy is correct. We just, in other words, don't test that, and grab the hierarchy from the JSON.
Scroll down. Oh, yeah.
Which is
Scroll
way down here.
right, but we need the hierarchy.
This shows
from,
the hierarchy.
Yeah,
so
but
I
we
can
need
analyze this to get the hierarchy, and then just anywhere I see this file name.
But it's not necessarily the same file, right? It
right,
could be files of the same name, different size.
Yeah, there might be multiple file names with different sizes. So
scroll down to the top. Scroll down. I have an idea. Where's it displaying where does it start displaying the circles? Because everything starts in a single circle, right? So it won't. It'll be above that because that's the script.
hierarchy
root.
This is it. This is the beginning of the script.
Oh, that's the beginning of the script, but I'm looking for the beginning of the data that's being displayed.
Oh,
where's the root?
In the SVG?
Yeah, the top circle.
Scroll down. The SVG begins right there.
Right there. Okay, so what does it say? Circle
root.
class node root. So that's going to be I'm guessing that's going to be the biggest circle, right?
Yeah.
And then there's class node and testing naturalistic data housing law. Is that a directory name? No extension on it, so it's probably a directory name. Testing crafted data random text. That is a directory name. I remember that just from Like go to your DOS window. Okay, and go up cd ... and cd ... again.
Don't we want to do, is it CD dot or dot? I always, okay.
To go up.
Yeah,
cd ... one
goes
more
up.
time. Okay, now do it, just type dir. And I predict that we will see something that says, oh no, dir/d. Is it /d for directories only?
I
Oh,
think
but
what you
look,
do is
look,
B.
it doesn't matter. There's a first order example of it being right, because there's the data Brian's thing that we see in the other window. If you flip to the other window, that is a folder name, and that's right scroll or right in the center of the screen. It says ID testing crafted data DeBrian. So first order evaluation there. That is a folder name, and it is a node. So that means it's a container for other circles. It's a circle that's a container for other circles, right?
Yeah, class node, as opposed
Okay.
to class node leaf, I guess.
Node dash leaf.
This is node leaf.
Right.
And this is talking about a particular file, clearly, right here.
Right, because that's an MP4. It's got to be a file.
Yeah.
So we've got everything. We've got whether it's a node or not. We've got
well, we don't know what we don't know whether we don't know which circles belong to which directories,
which parent circle.
Except that we can do a simple geometric analysis by looking at these coordinates. We can find out if this coordinate right here lies inside of any other circle. So I can pull out all the coordinates, and then I can tell you which coordinates lie inside which other coordinates, which other circles. So I can reconstruct the hierarchy from that. So I could do that.
So to sum up, I guess what we're saying is, if we actually wanted, if we had some crazy program manager who said, no, I must be sure that the circles inside each circle are mathematically correct and precise, we could do that if we decided that the value of doing so were met by the cost of doing so. Is that, we could get perfect
if we needed
analysis
to,
of every single circle.
If we needed to, we could independently verify that the display the display data structure, I should say, correctly represents the input data structure.
For every given circle.
Well, not only for every given circle, but it just occurred to me, it's also for every zoom level, because what you have here, the circles have a certain size.
Right.
Oh, you know what? But I wonder if, I don't know how this is working, but it might be that when we zoom in, that doesn't change the SVG data structure at all. It just changes the way it's being displayed by the browser. So it might be that it doesn't matter whether you're zooming or not. That's just a browser thing. And that all of the data is still going to be exactly the same. So that whether I'm zoomed all the way out or whether I'm zoomed all the way in doesn't make any difference from the point of view of testing what we need to test.
For the
proportionality. I don't know whether that's true or not, but there's a simple way to find out. What we could do is look at the SVG right now based on this, and then zoom in and see if the SVG has changed at all
in another subsequent version of the DOM.
And I bet maybe it hasn't changed. I'll bet it hasn't changed. It's exactly the same SVG.
Let's look at it. Let's try it.
Okay, so here we have, I'm maximally zoomed in.
Right.
Okay, so let's just find one node, and then we'll find that same node and see if that has changed at all. So here's how we do it. We go and
wait, I got an easy way to do that. Why don't we put in a file name that is distinct from any other file name that's in there already, and we'll be able to zoom, or we'll be able to go to that one right away.
Yeah, good point. Good point.
Unique data.
Right. So there is an example of that, I'll bet you file different hint slides. There's got to be only one of those. I know this directory.
Okay, well, go.
Ramius. I know him.
I
I know
don't.
his ways.
I don't
So,
trust you. Go to the
file-
go to the DOS window. Go back to the command
Okay.
line window.
Why?
I've got a quick test for this to see if we can be sure that you're right.
All right. You want to
So
actually
bring it up. Bring up the
test the
command.
hypothesis?
Yeah.
Okay. Sure.
So
Yeah.
a dir file differ hint slides. You're in select mode. There is the issue, I think. Why you can't type. Hit escape.
What am I trying to do?
Look at the top of that window. It says select command prompt. You want to hit escape in there so you can start typing properly.
I don't see anything like what you're. Though this.
Yes. Look, there you go. Now you're good.
What are you trying to get me to type?
dir
Yeah.
space file
Yeah.
differ hint slides, and then scroll that up so we can see the bottom of your screen, and /s though, to make sure that there are no other instances of that file. Yeah, that's good. So add a /s to that. Yeah, subdirectories. Okay, so it's been through the whole.
Is that how that works though?
That is how that works.
Really? So
Yes.
if I say, what was that other one?
Common one.
What was
all
one?
Viewer, all viewer star.star /s.
All view. Oh, it's hard to see in this thing. All viewer star.star
/s.
There's only one of those.
No, there's two. Look.
Oh, you're right.
There's lots of them, in fact.
Yeah. Okay. You expect me to look at the screen after I run a command?
Is this one of those today I learned
people who do that for me?
Is this one of those today I learned things for you where you weren't aware of the /s?
Well, I didn't know about that you could do a
recursive
dir /f that was. I knew you could do a dir /s. I didn't know you could specify a value and essentially look for a file through. I didn't know that.
Today's a wonderful day.
Okay. So
that's cool. Okay, so we know that file differ hint slides is the only one that's in that directory structure.
Right. Okay. So
that's good.
Let's find file differ hint slides. Here it is. Right now it's R340. Okay, it's R340 when I've zoomed way in.
Okay.
So now I'll zoom way out. And then we go back here and we look at file differ hint slides. And what we have is, oh, look at that. It's 17.
It's changing on the fly.
So it does change. I thought it might leave the SVG alone,
but it doesn't.
And just change the view on it somehow, change the camera position, but nope, it actually changes the SVG itself. Therefore, we probably have to test this thing at different zoom levels.
Well,
rather than just at one.
What I want to take issue with something that you just said, which is have to.
Yeah,
I mean, we might want to. We might want to if we want to test.
If you want
to this degree,
you want to sleep at night. You don't have to lock your door. You don't have to put gas in your car. You don't have to eat.
But this to me is not exactly.
These are choices.
Right, exactly. These are choices, and
I'm going to make that as a suggestion: is to go to maximal zoom level and then analyze the thing from there, and then go to minimal zoom level and analyze it from there. So just two, not every intermediate zoom level, but maybe just the two.
But it is really cool. I want to emphasize, it's really cool that you had this idea that it wasn't changing the SVG, but we did a quick test, a quick simple test with by what were the heuristics that we used in order to perform that simple test? We used the unique data point heuristic, which is, well, it's a spot check, isn't it? We spot checked one particular uniquely identifiable data point, and we did the analysis of that data point.
Well, we're also trying to eliminate confounding variables to some degree. We're by focusing on one file,
right,
and making sure that that file is unique.
Yeah. And then we did a simple test of going to making one change, right? One change at a time. We changed the zoom level, and then we observed the effect that that would have. That was the principle of concomitant variation, wasn't it? From John Stuart Mill. We made a change in the display, and we wanted to see if there was a concomitant variation in the data, and it turns out there was.
And we didn't.
And you thought
we
there
didn't
wouldn't be,
actually.
but there was.
We didn't say that out loud, but the fact that it went from a large number to a small number was interesting, because when we zoomed out, the number got smaller, which exactly makes sense. It went in the right direction, because that large number represents radius. At least that's my theory. You know, I haven't looked this up in the SVG specification. I'm doing sense making right now, and I'm guessing based on the fact that this is a circle object, and then there's a letter R, that R stands for radius.
And then the 2 points identify the location of that circle.
The center of the circle
The
is
center
what
of the
I'm
circle.
guessing.
Although that's interesting, it says transform.
Translate.
Translate.
Yeah, transform, translate, right.
But 1347 7256, that can't be pixels. What do they represent?
I think they represent some unit of measure, and I don't remember they might represent millimeters. They might represent some abstract unit of measure.
It's
I'm
millimeters.
not sure.
If it's millimeters,
I'm not sure what it represents, come to think of it, but it's some fixed unit.
If it's millimeters, James, it seems to me that you've got a screen that must be 7 meters across. So are you actually at JFK RFK Stadium?
No. You misunderstand. This is not something that's being displayed on the screen right now. This is off the screen.
Translate?
Yeah, it's translated to a region that is not being displayed on the screen.
Oh wow, so it really could be that.
It's clipped. I mean, you see, look. I mean, file differ. The file differ hint slides. That's not on the screen right now.
Right.
It's way off in the 14 feet that way.
So it actually is possible that it's 7 meters away.
So if we zoom out, let's zoom out. And now if we zoom out, file differ hint slides has to be on here somewhere. In fact, I think it's up here somewhere.
It's tiny.
Right, it's right there, but now it's on the screen.
Right.
So if we look at this now, where's my
F12?
Yeah.
There you go.
Now it says, you see, this is something that is actually on the screen. So this might be pixels. It might be inches. No, not inches, millimeters.
On a
I'm
virtual
not sure.
Screen. Yeah.
We can look it up in the spec, but it's some kind of fixed measurement unit.
And that's in the SVG spec, is that right?
But this is something I'm concerned about. It says 25 here.
Well,
25 millimeters. If that was 25 pixels, that would be.
Zoom in. Let's have a look at it.
Let's bring our thing in. If it's 25 pixels, it would mean that the diameter of that circle would be actually pretty big if it was pixels. So where is this thing? Can we zoom in on this? Let's try this kind of zoom. Not a very helpful zoom.
No, that's the browser, just the general browser screen zoom. What folder is it in?
Can we even see that? It's got to be in the main folder. That's why it's out here.
Oh, I see. Okay.
Can you see that? I don't even see hint
No,
slides
I
in
don't.
there. Could
So,
be, but
oh, file different hint slides is there though,
where?
right there, on your right.
Oh, there it
There,
is.
there it is.
That
File
must be
different,
it. Must be right there then, because
but we
it's
can't see the dot that it refers to. Is that the one? That's the one that's
right
centered?
here. Right
Yeah,
here.
okay. So bring your ruler up.
Well, let's make it 100% zoom. So that's it. So let's take a look at how big that
Yeah.
actually is. And that is,
Well, it's pretty close, isn't it?
it's 26.
26? You said 25.
Yeah, but that's an R. It gave us R, right? A radius. That's a diameter. We're seeing a diameter of
Good point.
26. So I'm a little confused if it's saying
No, but no,
R25.
that's a different file name. File different
Oh,
hint slides. Go down
oh,
farther.
there it is,
14.
17.
Yeah,
Oh, so it should be 34.
no, yeah,
Should it be
farther down.
34?
That's the PD. No, you're looking at the PDF.
Oh, right here.
No, the one
PPTX.
below. No, it's
Oh,
not. You're looking at PDF.
oh,
But
14.
PDF is there, 14, which is just about exactly 30. So it's 30 pixels.
20. Okay, yeah. So that, all right. So yes. So it might be pixels they're talking about.
It's in
Probably is
pixels, and
pixels.
when you zoom it up, when you go down into a folder, deep, like that, and then on the upper right, like that, then
This
it seems,
has,
yeah,
oh,
then it
where is it
seems,
now?
then it's
66.
66. So it's creating a virtual screen that is of that size, I guess. When you
Yeah.
zoom in,
And
it
if
creates
I
a virtual.
could, I don't have the ability to scroll around this screen. I don't have the interface to do that. But if I did, in principle, I'd see a 66 size. And now it's even bigger. And now it should be quite sizable. File different hint slides 204.
And I bet if it's so it's 408 pixels wide, I bet. You bring up your ruler.
Yeah, well, it's, yeah, 408, but we can't see it. It's off screen.
Right.
But in principle, well, yeah, I mean, we don't need to go any more into this, but we've established that the SVG changes when you zoom. And that way, because of that, I may need to do some tests at different zoom levels to see if all of the proportions are preserved during the zoom, in case that matters. But that's
So all this is pretty cool. I mean, if I were a program manager, and I've been a program manager, if I were a program manager for this product, and the idea was that we've got something that's intended to visualize the amount of space taken up by files on your system, there's a fundamental issue right away, which is that the size of the circles themselves cannot be correct because to pack a bunch of circles into another circle, you're going to need a bigger circle. That is to say, what we're seeing right now on the screen, if all those white circles are proportional to one another, that's cool, but they're not going to be consistent with the size of the circle that contains them, because the circle that contains them needs some breathing room around each circle. So the circle that contains them is going to be disproportionate to the size of the individual circles within. On the other hand, as somebody who's just looking at this and trying to see, all right, well, where are the really big files on my system? This is fine because I can see really big files this way. And so that degree of precision is probably not important to me. But if it is important to me, there's a great, hey, make that 0, 0.
well, I was trying to make it 200, 200. I was trying to put it on the screen.
Yeah.
And to see if I could move the circle onto the screen, but then
It's not rendering it.
It's not rendering it, I guess, or else my theory is wrong.
Yeah.
Because you certainly don't see it there. But then I found that when I moved out, was there anything there? No. Okay.
All right. So to go back to what I was
Doesn't
saying,
matter. Yes.
If we want to analyze this to that degree, it is immensely easier to do that with just a little bit of testability. And that testability wasn't hard to add. It's just not that difficult. And I mean, we did that. What was the actual activity of doing that was maybe 10 minutes, 5 minutes.
Well,
You know.
what you need is the certain basic knowledge, certain basic expertise, which we happen to have at this time because we developed it at an earlier time.
Right.
And you also saw during this process that we're developing new expertise as we experiment with things and come to understand it. Now we're going to apply that so that the next time I work with D3, I'll just be able to do it quickly.
D3 is a drawing library that
yeah, this is the drawing library that we're using here, which is a popular library for presenting complex data displays. And
okay.
This is an example, though, of the basic principle. It begins with, if something looks complicated and you have to test it, you don't have to give up. Maybe your first question can be to ask for testability. And that means we need to conceive of what testability means. And amongst other things, testability means observability. I want to be able to see something and see all of it and see everything interesting about it. In this case, we couldn't see what file was associated with what circle, so we took action to improve that. And if I didn't have the skill to do that, if you didn't know how to do that, then we would approach the developer. Although there is a danger, which is often the developers, in my experience, will say, oh, I don't have time to do that. And if you know just enough about the technology, you might be able to say, surely all you need to do is add a little ID. That's all we want you to do. That's just a line of code.
Or not even an ID, but you could add an attribute of any name, couldn't you? It doesn't have to be an ID. You could say, because HTML is permissive of this sort of thing, you could say testability hook equals file differ hint slides.pdf.
Really? And it's not going to cause any kind of error?
Let's try that.
I think we have to try that now because I didn't think of that. And if I didn't think of it, then we have to try it. So instead of ID, all we have to do is say,
yeah, right.
James's great
testability hook.
Testability hook. And our hypothesis is it will still render the SVG just fine. Maybe we'll get something in the console complaining about something. I don't know. Let's just find out.
Yeah, I love the James's bit, by the way. Like it's not Michael's.
No, because I'm the one learning here. You already knew this was possible, apparently, if it is even possible.
I don't know. I don't know. I'm guessing. We're testing.
Okay, so now I've certainly we see something.
We do.
We see something. Now let's see it over there. James's testability hook equals. So we have that. Now in the console, is there anything complaining? No errors in the console.
And the warning is not relevant to us. It's not
even a thing. It's something, it's a security thing. It's a cookie security thing. So
if the developer says, oh no, we can't add IDs to it because it might collide with some other mechanism, you can get them to add anything you want. Right.
Right, because all I'm going to do with that is pull that out and use the data to perform a calculation of the different proportions.
And that can go into a debug build, for example, right? So, boy, that's great. That's another thing that we've
Okay.
added to our arsenal of testability tools, which is we can have crafted testability. We can have
Okay.
identifying data in there. That's wonderful. I
Okay,
was pretty sure that would work.
let's call this to a halt then, and